Equation of a straight line. Alright, so today we're going to be looking at the equation of a straight line, which is in the general form y equal mx plus c, where both m and c are constants. They are real number, they have number values. M here represents the gradient, while c represents the y-intercept. So then, in order to identify the gradient and y-intercept of any particular equation, it must be written in the form y equal mx plus c. So then, if I look at this particular equation, which is 3y is equal to 2x minus 3, in order to determine the gradient and y-intercept, I need the equation to be equal to y. Y must be the subject. Currently a is equal to 3y, so I must get rid of the 3. And 3y is 3 times y, so the reverse of multiplying would be to divide. So I divide each of the terms by 3. And my result becomes y is equal to 2 over 3x minus 3 into 3, which is 1. Here I can identify my gradient is 2/3, and my y-intercept c is now negative 1. Let us look at another sample problem. Given the equation 5x plus 2y is equal to 10. Here we have 5x plus 2y equal 10. And I want to identify the gradient and y-intercept of this particular equation. So then I'm going to have to get it to equal to y. In other words, I am making y the subject of the equation. So to reverse this, I reverse the addition of 5x since I want to have y by itself. And what I do to one side, I do to the other side. So I will also subtract 5x from the other side. This will cancel out, giving me 2y is equal to 10 minus 5x. I am still not finished yet. I currently have 2y is equal to 10 minus 5x. To get rid of the 2 that is multiplying the y, I will divide each term by 2. My answer now is y equal to 5, as 2 into 10 goes 5, minus 5 over 2x. My gradient m is then negative 5 over 2, and my c value is 5. Please note, the gradient is always the value multiplying x. The gradient is always the coefficient of x. So in order to identify the gradient and y-intercept, the equation must first be written in its general form, meaning it must be transposed to make y the subject. Additionally, if I am given the gradient and the y-intercept, or the coordinates of the y-intercept, I can write the equation. Example, if I am to determine the equation of a line, it says determine the equation of a line with gradient half and passes through the point 0, negative 3. If I want to determine the equation of a line with a gradient of a half, with a gradient of a half, with a gradient of a half, and the coordinates of the y-intercept is 0, negative 3. What that then means is that this point lies on the y-axis. How do I know that it's on the y-axis? If the x value is 0, the point is on the y-axis. And if the y value is 0, the point is on the x-axis. The fact that this point is on the y-axis and the line passes through it means that the y-intercept c is equal to negative 3. The y-intercept c is equal to -3. So then if I have my gradient and my y-intercept, the general form is y equal mx plus c. So I simply substitute m, a half, and the value of c, which is -3, and I have my equation of the straight line that has a gradient of a half and passes through the point 0, -3. Now remember, if the y value is 0, if the x value is 0, then the point is on the y-axis, and if it is on the y-axis, then the y value given is the y-intercept. Let's take a look at an equation where we are given the gradient and a point, but the point is not on the y-axis. So let's take a look at this particular question. It says a straight line passing through the point -p, -3, and has a gradient of 2/3. Write the equation in the form y equal mx. So now we have the point P, and P has coordinates -3 and 5, and has a gradient which is 2/3. Now when we're given the gradient and a point on the line, and we want to determine the equation, we are going to utilize what we call y minus y1 is equal to m into x minus x1. Now y1 and x1, these are the coordinates of the point, while y and x, these are variables. They remain as variables. They remain as variables. So since this is my point, this then is my x1, which makes this one my y1. Substituting into the equation, I have y minus y1, which is what is going to be replaced, is the y1 and the x1. So the only thing to be replaced is y1 and x1. So it then becomes 5. Replace the m, the gradient, which is 2/3. X remains. Replace the x1, which becomes -3. Now remember, the subtraction of a negative becomes the addition of a positive. So this becomes x plus so that becomes x plus 3. Expanding by multiplying by 2/3 becomes 2/3 x, but 2/3 times 3 becomes 3 into 3, 1, and 2 times 1 is 2. Now to finalize, we need to have y by itself, so the reverse of subtracting 5 would be to add 5. And remember, what is done to one side must be done to the other. So I also add 5 to this side. These will cancel out, leaving me y is equal to 2/3 x plus 2 plus 5 is now 7. Hence, this is the equation of my straight line. So to get the equation of my straight line when I'm given a point that is not the y-intercept and the gradient, I use what we call the point-intercept or the point-slope-intercept form, where I use y minus y1 is equal to m bracket x minus x1. And remember, for this form, you're only replacing y1, m, and x1. Y and x remains as constants. Sorry, as variables. Thank you.